Hi everybody, today we're going to be doing half reaction method of balancing redox reactions. Our problem is to balance the equation occurring in basic solution. We are given I minus plus MnO4 minus that goes to I2 plus MnO2. And in class, to help us with this problem, we are going to be looking at our method for balancing redox reactions. So in step 1, we need to recognize the oxidation and reduction. And step 2, we need to separate the overall process into half reactions. Step 3, we have to balance by mass, and we are either adding an OH depending on whether it's an acidic solution or a basic solution. And step 4, we are going to balance by charge. Step 5, you need to multiply to make the electrons even so they can cancel out in the end. Step 6, you add the balanced half reactions. Step 7, you're going to eliminate the common reactants and products. And step 8, you check the final result for the mass and charge balance. So first we're going to start off here by determining our oxidation number so that way we can determine which element is being oxidized and which one is being reduced. So first we're going to look at iodine. We know that's going to have a -1 because it is given to us already. And we know that MnO4, oxygen is always going to have a -2, so that will help us determine Mn's oxidation number. So you would multiply that -2 by that 4 to get the number up here, so that way that will help you get the Mn's oxidation number, and it has to equal -1 because that charge is given to us already. So for that to happen, it needs to be a +7. That means Mn's oxidation number will also be a +7. For iodine 2, the oxidation number of this atom in an element is going to be 0, so that's why that will be 0. And MnO2, we know that it's going to be -2 for oxygen. Multiply that to get -4. It has to equal 0 because there is no charge on it. So to get that to equal to 0, we need to have a +4 for Mn. And that will be the oxidation number for Mn. So we look at the oxidation numbers to help us determine which one is being reduced and which one is being oxidized. So we see that iodine is going from a -1 to a 0, and we see that manganese is going from +7 to +4. So we'll write it down so that way it's visual. Well, iodine, which tells us that it is losing 1 electron and therefore is being oxidized. For Mn, we know that it's going from +7 to +4, will be gaining 3 electrons, therefore being reduced. So next what we're going to do is balance by mass. So we'll start off with making our half reactions, and it will start with iodine. So here we see that iodine here has 2 and this one has 0. Therefore, we need to put a 2 in front of the iodine to make it balanced. Next, we're going to look at MnO4 minus. This goes to MnO2 solid. And we see here that Mn is balanced by mass. Therefore, we don't have to add any numbers. Next, we need to look at oxygen. And here we see that there's 2 on the product side and 4 on the reactant side. Therefore, we need to add water so that way the oxygen will be balanced. And that balance will need to happen on the product side, so we will add 2 waters on the right-hand side. Next, since we added the 2 waters, we need to balance those H pluses, and that's where we will add 4 H pluses on the left-hand side. So again, because it is a basic solution, we have to refer back to our table over here. And in a basic solution, we need to add OH. So here, we'll add OH to both sides. So here we see that this is going to add up 4 waters. Now that we have the oxygen and the hydrogens balanced, next we have to balance by charge. So we'll rewrite this, and we'll add the electrons to both equations. We will be adding 2 electrons on the right-hand side. It will be on the right-hand side because anytime an element is oxidized, the electrons will be on the right. Anytime an element is reduced, it will be on the left. So that way they will end up canceling in the end. Next, we will look at the Mn and add the electrons on the left-hand side. And since we did it before, it's gaining 3 electrons, so it will be 3 on the left-hand side. So we see here the charges are not equal to each other. So we need to make them equal. And by doing that, iodine will need to be multiplied by 3, so those electrons will equal 6. So we're going to rewrite this down here. Next, we multiply by 2 for the next line. So we have 6 electrons, 8 waters plus 2 MnO4 goes to 2 MnO2 plus 4 waters plus 8 OHs. Next, we're going to add them together. This will be where we eliminate the similar reactants and products. So here we'll eliminate the 6 electrons because they're on opposite sides and adding together they go away. We see here that this water can go away and this water can be reduced to 4. Next, we add them both together. Which gives us the final equation that is now balanced and correct based on the methods that we followed. Thank you.